All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for Murachs, JavaScript and jQuery 3rd edition as part of the AWD Application and Web Development 1000 Web Technologies class. I'm on Chapter 13 of 18, and as you can see, the chapter is entitled How to Work with Numbers, Strings, and Dates. We have 2 applied objectives and 7 knowledge objectives. Our applied objectives, we want to be able to use properties and methods of the number, string, and date objects or date classes in applications. Use the random method of the math object to generate a random number within a specific range. Describe the special numerical values infinity, negative infinity, NaN, which is short for not a number, number.max value, and number.min value. Described how to use the 2 fixed and 2 string methods of a number object. Describe the pi property and how to use the math object methods ABS for absolute value, round, ceil to round up, floor to round down, pow for exponentiation, SQRT for square root, max, min, and random. Describe the length property and the string objects charat, concat, index of, substr, substring, 2 lowercase and 2 uppercase methods. Describe how to create a date object with the current date and time, or for a specific date and time. Describe how to use the date object methods toString, toDateString, toTimeString, getFullYear, getMonth, getDate, setFullYear, setMonth, and setDate. And finally, describe the type of coding that's required if you want to do date math. And really the only date math that you can do is to add values to dates, subtract one date from another, add one date to another, etc. So, the first thing we talk about is the number object. You notice it's number dot because there are 2 different objects. There is a number object and there is a math object. So the number object deals specifically with numbers. Like number.max value, I believe, is the biggest integer value that your machine can hold. Number.min value is the smallest value that your machine can hold. Number.positive infinity, well, hopefully that just makes sense as far as what that is. And number.negative infinity, same thing. Number.nan we talked about a little bit earlier. That stands for not a number. So if you attempt to do math and the value or values that you use when you are doing the math are non-numeric, the result will be NaN. Now they've got examples here and here. There's if results infinity or negative infinity if it's not a number, etc. 0 divided by 0, notice it says there, displays not a number. 10 divided by 0 displays infinity. All right, you can also, and this 2 fixed is really nice if you're working with, for example, dollars and cents. When you think about it, because 2 fixed would say that I want it to 2 decimal places. All right, you can also work with bases where you, if you don't put a value in there, let's assume that you're working with decimal or base 10. But I believe that you can also come in there and you can use basically like base 8 for binary, base 16 for hexadecimal, and base 2 for binary, base 8 for octal, and base 16 for hexadecimal. The math property has got, the math object has got 1 property, and that's pi. And it returns pi to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looks like 15 decimal places. Some of the commonly used methods with a math object, ABS for the absolute value. So for instance, if I'm 61 and my friend is 53, there's 8 years between us. It doesn't matter if it's 61 minus 53 or 53 minus 61. But 53 minus 61 would give negative 8, so you'd oftentimes use an absolute value on a calculation such as that. Round will round up to the closest integer. If the decimal portion is 0.5 or above, it'll round up higher. If it's less than 0.5, it'll round lower. Math.seal will always be rounded to the next highest integer. I believe even if it's like 3.1, it'll round to 4. Math.floor will always round to the lowest integer. So I believe even if it's 3.9, it'll be rounded down to 3. Math.pow. So for instance, if I say math.pow 3, 4, that means 3 to the 4th power. 3 times 3, 9 times 3 is 27 times 3. In other words, it's 81. Math.sqrt returns the square root. Math.max returns the largest value that you give it, and math.min returns the smallest value that you give it. Here are some examples. What I like about this book, you may or may not, but one of the things, I should say at least, that I like so much about this book is when the author will give you a problem or something like this, then typically what he will do is he will show you a bunch of problems that you would use with it, and then show you what the results of each of those calculations, etc. would be. Notice math floor always rounds up. Math seal, I don't know if that one's right. Oh, ceiling, yeah, rounds up. Floor rounds down. When you're working with negative numbers, floor will give you -4. That's the next highest negative number. Ceiling is the next lowest negative number. So sometimes the results are a little bit maybe different than what you'd expect. There's some power. I already told you one. I think this would give you the cubed root right here. And you can see the min-max examples. Next, let's talk a little bit about random numbers. With any programming language, JavaScript included, when you run the Math.random function, you get a random number that is greater than or equal to 0, but is less than 1. There are a lot of different ways that you can use this. A way that's oftentimes used is something like this. Get random right here. Okay, what that will end up doing is it will give you a random number between 1 and 100. Sometimes you want to allow the user to put in their own range. But for instance, if I went from 0 to 100, that might be the valid range for a test, as an example. You often use random numbers with games and other applications that provide animation because you want to have randomness. So you want to randomly move around a board or whatever. You could do that. All right. For whatever reason, in the next 1, 2, 3, 4 pages here, next 4 pages, the author has chosen to show the user interface for a game called Pig. The application, as it says, requires the use of just one die, and it illustrates the use of random numbers. When the application starts, when you look down here, the 2 bottom rows are hidden. Then the players enter their names into here. And then they click the New Game button. From that moment on, the players take turns until one of them reaches 100. All right. For each turn, the user can click the Roll button, and they can click the Roll button 1 or more times. Then a player can click the Hold button and keep the points they have during that turn. If they roll a 1 before clicking the Hold button, the term ends and they get 0 points. So for instance, I could keep getting 6s and 6s and 6s and be going up, and all of a sudden I get a 1 here, and I get a 0 for that turn. So the application is shown here on the bottom. The picture is shown on page 381, and underneath the picture is the HTML. This is just a subset of that HTML. The application consists primarily of labels, text boxes, and buttons, as you can see right here. and even a field set, it looks like, in here. The section at the bottom of the HTML has an ID of turn and doesn't have a class attribute. The section is hidden when the application starts because the CSS sets the display property to none. To display it, the JavaScript adds a class named open to the element, and the CSS class is then set to block. Now, what they don't show are the screen elements for the JavaScript files. This example uses jQuery for DOM scripting, so the first script statement identifies the jQuery library. In fact, the JavaScript is shown in the book on page 393. I'm chosen not to go over it, though. I'm going to go on and next go over the string object. One thing that many, especially novice programmers, don't realize is the fact that when you work in IT, that you work with strings all the time. We've worked with strings back in Chapter 2 and Chapter 4 and in other chapters. All right? What you see here, and this is the same table that's shown on page 385 in the book, are some of the major methods that are used with the string object. I use char@, a lot. If I'm writing an application where I ask the user if they want another turn, whether it's a game or something else, if they want to do it again, I'll tell them to answer Y or N. Y for yes, no, N for no. But the chances are that at least with some people, they might enter the entire word yes, or the entire word no, or something else. So what I do is I tell them to answer something, and I grab the result of that, and I put it into typically a variable called something like response. Then I run the char@ function to just grab the 0th character. Remember, we start counting at 0. So if they typed in yes, it would type in just the Y. Then I run the to uppercase function on it, so it becomes uppercase. And then I can say if that first character is equal to uppercase Y. All right, then I can do something, otherwise do something else. Concat allows you to glue strings together. You can also use the plus sign for this. Index of starts searching the string for the first occurrence of a string. If it's found, it gives you the position of the string. If it's not found, it returns -1. Sub-str has got a start and a length in it, as you can see. It returns the substring from the start position through the number of characters specified. Substring with start returns the substring from the start position all the way to the end of the string. Substring returns the substring from the start position to, but not including the end position. 2 upper and 2 lowercase hopefully are pretty self-explanatory. And there are a lot of examples then on the bottom of page 385. Now you work with strings a lot. Okay, you end up working with strings a lot. Now they show here in this first example how you can trim the spaces off the beginning of a string by using a function that's named trim. Typically most programming languages have a trim method inside of them that removes any leading spaces and any trailing spaces at one time. Notice they've got an L trim for trimming it from the left, an R trim for trimming it from the right, but most of the time, okay, you'll just combine those into trim. Now, I'm going to check something because I always get confused with this. But I'm going to come in here and I'm going to key in JavaScript trim function. And you'll notice, according to W3 Schools, there is one. All right, that's what I thought. This will, as it says, that will take and remove all of these initial blank spaces, all of these trailing blank spaces, but it will not remove the blank space in the middle. So we got to try it yourself. And notice we've got there hello world. So I'm going to try this. I'm going to put in space, 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 Jeffrey, space, P dot space, Scott, space, space, space. And when I run it, you can see, well, I get hello world. Don't know if there's a way to save with this. There we go. And it removed all the leading and all the trailing spaces. Now, how would I know for sure it did that? Well, what if I did this? I'm going to say var len, for length, equals str dot length. And I can't remember if it's an upper or lower case. So if it's lowercase, this isn't going to work if I did it in the wrong case. And I'm going to say alert, the length is len. Let's see if that even worked. So we'll go ahead and try it. Doesn't like something that I did. It might be that this is a capital L. I don't know. Let's try that. No, it might be that it's a lowercase l. I always forget with length. And it might be that it does not have, so it looks like that without the parens. Let's try that. All right, the length is 22. Now, I'm going to go and put in the same line, the same code. Come on, fine. It's not letting me, oh, there we go. Not letting me come on. Oh, all right, that's fine. So let's come back after we trim it, and we're going to put the same code in there. So before trim, the length is, and after trim, the length is. Okay. Now I don't need this alert, which is just giving me the name, so I don't need that. So let's see what we get now. Before trim, the length is 22. After trim, the length is 22. Oh. Because I never called the trim function. So let's do that. str equals str dot trim. Okay. So before it's 22, after it's 16. So it removed all of the leading and all of the trailing spaces. Get rid of that. All right, it's a little early, I think, but I am at just about 19 minutes, and I'm a little more than halfway through the chapter. There's ignoring case, and you can literally tell it to ignore case, or you can use the two upper and the two lower. So before we go into date objects, which are next, and again, I've got a very good start on this project, 2, 3, 4, 5. Let's just keep going. We can probably finish this, and it'll only take 5 or 10 more minutes. So the next thing that's discussed, beginning on page 388, is the date object, which can be used to represent the current date and time. If you call the date constructor and you give it no parameters like this right here, it creates a new date object that's set to the current date and the current time, all the way to the nearest millisecond. If you call it with a string as the parameter, the constructor parses the string as a date or as a date and a time, and it creates a new date object. But you might get unexpected results if you don't use slashes and you don't use 4 digits for the year. So here's some examples. Now in JavaScript, dates are always represented by the number of milliseconds that have passed since midnight, January 1st, 1970. If you want to look up that and see the significance of that meaning, you can look up Unix epoch, or epoch, E-P-O-C-H. All right. When you create a date object, the dates and times are specified as local time. In other words, it's based off of your browser. Month numbers start by default with 0. So January is 0 and December is 11. The reason for that is it makes it easier to use dates with arrays. As far as, well, there's the invalid date and an invalid date, okay? Notice with the 18, it's 19. It doesn't understand that. This is what I just mentioned to you. All right. Some of the formatting methods you can use with a date object include toString, which returns a string containing the date and time in the local time zone of the client machine or the user's machine. ToDateString, which returns a date representing just the date. And ToTime, which returns something representing just the time. And you can see some examples right here. There are several get methods and set methods of the date object. And these methods, except for get time, they use the time zone specified on the user's computer to work with local time. These are what are called complementary things. So get full year allows you to return the current full year. Set full year allows you to set the current full year. Most of them by their names should be pretty self-explanatory. So what you're doing is parsing or grabbing out part of the date. All right, so you can grab just the year, just the month, just the date, the day, the hours, the minutes, the seconds, etc. And again, many of these things start with 0 as opposed to starting with 1. Here's an example that's shown on page 393 of how to display the date in your own custom format. You first create a new date object with a date and a time. Then you extract the year, month, and date. You add 1 to the month number so it's not month 0. Then you build a text string so this looks a little bit nicer. All right, so it looks more like this. Dates are kind of a curious thing because whether you're aware of this or not, the universal date indicator that's used, like I said, universal in most countries is not a hyphen. It's not a /, it is a period. All right, JavaScript typically supports as much of this stuff as it possibly can. All right. So, pages 394 through 397, which is the rest of the chapter, illustrates the use of strings and dates by presenting a countdown application. It accepts an event name and an event date, and it calculates the number of days until that event occurs. To do this, it uses a date object for the calculation and a string object for the method, for the message rather, that we'll display. So the HTML is shown on page 395. It's pretty simple. We got a couple labels, a couple text boxes, a button, and then another label down here. It uses several different IDs, which you can see here in yellow. Very little CSS, just to make sure that our message appears in red and bold. That's about it. Now, the JavaScript for this is shown on page 396. The ready function contains just one event handler for the click event of the countdown button. It starts by getting the event name and date that the user keys in. Next, the code starts a series of data validation checks. It checks the length property of the string object to make sure that the user entered something for the event and for the event date. Next, it uses the indexOf method of the string object to make sure that the date has been entered with slashes. Third, it uses the substring method of the string object to get the last 4 characters of the date string. Then it uses the is NaN or is not a number function to make sure that the characters are a number. Fourth, it uses the date entered by the user to create a new date object and then checks it to see if it contains invalid date. And based off of that, if everything is passed, it builds the message and then presents it to the user. All right, this stuff are the exercises at the end of the chapter. So that pretty much is it. When I return, which will be in a couple minutes, I'm going to go over Chapter 14, which is how to work with control structures, exceptions, and regular expressions. Some of this material we've gone over, but it's been kind of a light touch, for lack of better words, and now we're going to go over it in more depth and breadth of coverage, so I'll be back with that shortly.